So there it is. It's an example of why there are two answers most of the time. Look at 5b. This is for everyone, and this is a visual picture as to why it works. 5b. The equation of the circle is x squared plus y squared equals 25. Find the coordinates of the points where y equals 4. Sounds like there's 2 points to me. Anyway, let's just see, shall we? So here's what I did. I said U4, go in there because you're the y bit. 4 squared is 16. Take it over. X squared is 9. And I missed it yesterday actually because the square root of 9 is 3, but it's also minus 3. So when x equals 3, we know that y equals 4 because you're giving that in the question anyway. So I know the y coordinate 4 will have a corresponding x coordinate 3. But I also know that the y coordinate 4 will also have a corresponding x coordinate minus 3. Why? Well, I did a rough sketch this morning when I was thinking about this more closely. That's meant to be my x and y coordinates. I'm sorry, this graphics tablet is at an angle. This is the best I can do with a freehand sketch. Here's my coordinates, here's my grid, here's my circle, which is meant to be like this one here. X squared, y squared is 25. I drew in the line y equals 4. Can you see what I'm trying to do here? I drew in the line y equals 4, and of course it's going to cut in 2 places. It's going to cut there where x equals 3. Ta-da! It's going to cut here where x equals minus 3. Ta-da! That's why there's 2 answers. Okay, so the picture's really, really useful for you. So that's me going over question 5. Okay, now this lesson is dedicated to question 6 and for some of you question 9. But I'll do both and then you can choose what you want to do. Now, in order to avoid some glitch, maybe we could perhaps switch off our vids at this point, even though the video has started. And that's some of the really dodgy ones in question 5. Hello, Eric. This is question 6 and I will go large on that. Take a good look. I will read it slowly and go over it very slowly. The diagram shows, I'm reading from page 373, the diagram shows the circle x squared plus y squared equals 25. Oh, so the radius must be 5. I think they drew it rather well. It's a very beautifully drawn little graph. Trouble is it's little, you can't do much with it. Definitely passes through all the 5, so that's good. The radius of the circle at the point 3, 4 has been drawn. Yes, it has, and I know it's 5 centimeters long or 5 units long. That's not relevant for now. It says find the gradient of the radius. Okay, I'm now going to put my book back because it's in the way. The gradient of the radius, the reason I've called it m is because you know m stands for gradient, y equals mx plus c. Trouble is I'm trying to fit everything on one page, so I called it m of radius. Now, do yourselves a huge favour. For the questions you're going to do yourselves after this lesson shuts down, draw yourself a sketch of how the situation will look. So here's my circle that I drew, and that's meant to be that. I know the point 3, 4 has an x value of 3 in the horizontal direction and a y value of 4 in the vertical direction. And I know a tangent touches the circle at 90 degrees to the radius, always. If I was to draw a different radius for a different point and draw a tangent at that new point, it would still be a beautiful 90-degree touch, which is why we did it all before, twice, just for this question. All right, so listen up. So here's the point 3, 4. I'm 3 along, 4 up. Now don't do this backwards. How do you work out the gradient? It's difference in y divided by difference in x. So it's 4 over 3. It's not 3/4. Don't look at that and get lazy and don't draw me a picture. Because if you get lazy and don't draw me a picture, you're going to get this completely backwards. Draw a picture and ensure it's 4 over 3. Tick. Then what does it want? What's the equation of the line? through 0, 0 and 3, 4. In other words, what's the equation of that little radius there? Well, it's y equals mx plus c. The m is 4/3, and the intercept is always going to be 0, because all these radii come from 0, 0 for GCSE. So the equation of that radius in that direction is y equals 1 1/3 x's. Stop. Part C. Find the gradient of the tangent to that point. Oh, that's this orange line here. Orange line, completely at 90 degrees to that little blue one. Now you know that his gradient flipped and put a minus on is the tangent's gradient, is it not? Because 4/3 times minus 3/4 makes -1. If you can get it to work out to become -1, then you flipped it correctly with the correct sign. So they're gradually building me up to get the equation of the tangent to the circle at the point 3, 4. I now know the gradient of the tangent. There it is, -3/4. Part D. Work out the y-intercept of the tangent. Okay, so y equals mx plus c. So y equals -3/4 of an x plus c. Now I need to use the point 3, 4, because I know the point 3, 4 is not only on the circumference, but it is at the precise location where that orange line touches the circle at 3, 4. That's why it's called a tangent. It touches, tangent. So I've got to substitute 4 for the y and 3 for the x. And now it's just raw maths, I'm afraid. Can you multiply -3 times 3? I can. That's called -9. And can you divide by 4? -9 divided by 4 is -2 1/4, and there it is. So how do I get my intercept? 4 equals -2 1/4. That's that little bit of math there, plus c. Take it over and plus it. That's what you would do with a little equation. So the intercept is 0, 6 1/4. I finally know that point there is 0, 6 1/4. And to be fair to this little diagram with respect to it, if you look at the dotted line tangent, it does actually go a little bit above 6. It does. So they've done us a lovely little diagram, although practically invisible because it's size. So there it is. So that is the intercept of the tangent to that radius at that point. Now you put the two ingredients to bake the cake. What is the equation, finally, of the tangent to the circle which touches the circle at the point 3, 4? Y equals gradient of the tangent plus the intercept. Done. That's it. Now, of course, if you're really flash, you can multiply everything by 4 and get 4y equals -3x plus. Don't even go down that road. Leave it like that. Always leave it in the form of y equals mx plus c, unless they say rearrange it in different form. That's it. I've got a gradient, clearly negative. I mean, look at it. That's a negative gradient. Clearly, the intercept is about 6-ish, because even from the diagram you can tell it's gone slightly above 6. And that's it. That's what grade 8/9 looks like. And the instruction to Tino and to Jake and to anyone else is this. I've just done question 6. Do the same to 7 and 8. Let me just reiterate. Do the same to 7 and 8. Now, for some of you who want to get grade 8, watch this. This is question 9, and this is me working earlier this morning. Again, a crappy little diagram. And I did indicate yesterday, really, this is just a pair of simultaneous equations. Let me read question 9 for you, because this I will call grade 9. In fact, I took this further than what the question says. It says, find the exact solutions to these simultaneous equations. So that's a good hint. So I'm doing the first one. I've got to see where x squared plus y squared equals 25 intersects with y equals x plus 1. That's it. I've got to see where the two x values and two y values correspond. where at the points of intersection. So I'm going to write out my question. Yeah. Then I thought, I can't just, I'll do it this way. I said, well, let's get rid of the y's because I know y is worth x plus 1. And I'll take that little bit and put it right there. Can you see that's what I've done? Instead of a y squared, I've called it x plus 1 squared. Now all the y's have gone bye-byes. I ain't got to worry about y, not yet anyway. So multiply this little bit out. That's x squared plus 2x plus 1. Yeah, if you can't see that, do 2 little brackets on the side and then bring it back into the story. And that simplifies to this. Where does minus 24 come from, by the way? Can anyone tell me?
25 take away 1.
No, it's 1 take away 25. 1's there first, you bring over the 25 and subtract it to leave 0 on this side. Remember, we're setting up a simultaneous quadratic equation, or rather, a quadratic equation must be equal to 0. So there it is so far, 2x squared plus 2x plus 1 minus 25 is that. Oh look, these are all factors, multiples of 2 rather. So factor out the 2, divide everything by 2, and nothing divided by 2 is still nothing. And this is a really easy grade 5 quadratic to factorise and solve. These are the 2 factors. You multiply this out, if you can't see it, you will get that. So I've got x is minus 4, take it over and minus it. I've got x is 3, take it over and plus it. So I've now got the 2x coordinates where the circle and the linear equation cut through each other. So let's just work out the y, shall we? Okay, so I'm going to start with this one. Minus 4x, sorry, x is minus 4, put it in there. Y equals minus 4 plus 1 minus 3. Oh, so I've got the point minus 4 minus 3. This one. Pick up the 3, put it in there to find. Don't put it in this one, it's too complicated. Just work easy. Put that x right there, y equals 4. So I've got 2 points, minus 4 minus 3 and 3, 4. So I wanted to see what it looked like. So I did a rough little sketch like that. I can see my gradient is going to be positive, so I cut it across positively. This is going to be the points minus 4 minus 3, and this has got to be the point 3, 4. So I have answered the question fully. Now I know up to grade 9 they can go further. I know this, I've seen it. And they can say work out the length of the chord between the points that you've just calculated. In other words, how long is that actual chord from that dot to that dot? Answer, it's Pythagoras. Now, let me teach it because this is coming up in due course. From minus 4 to 3, again, I've not put it on a grid, I don't need to do that, I just need a sketch to visualise. From minus 4 to 3, yeah, I've got 7 units across. From minus 3 up to 4, that's 7 units up. Cool? So, how do you do Pythagoras? Well, wait for year 11. It's 7 squared plus 7 squared, and then you square root button it. I made that 9.9 to 1 dp. So the length of that chord from that point to that point is 9.9 units. Now, it doesn't ask you to do that, but this is going on video, and you will need to refer to this later on when we finally do finish off this topic and hence the chapter. It's long because it's a high grade, and some of you want a high grade, therefore you need to be able to do this. You should be able to do this, it's just simultaneous equations, it's not difficult, but this is the little extra where Pythagoras is involved in working out the length of the chord. What's next? No. That says AQA homework. I told you you're going to need it. Yeah, the AQA set a question exactly like that. So try not to